Alright guys, so here's your shape and skewness of a dot plot. This is going to go over TEAC 7.12a. Again, not really concerned for you guys to understand TEAC, but here's what you guys need to get out of these video notes today. So your learning target or your learning statement is, I can identify and justify the shape of a dot plot. So basically what we're saying is that you guys should be able to identify, which means look at and see and be able to tell the shape of a dot plot, and then be able to justify why you picked your answer. Okay. All right, so let's talk about shape of dot plots. So in 6th grade, you guys talked about shape a little bit, about symmetrical, non-symmetrical. If you don't remember that, that's okay. But we're going to talk about it in 7th grade. Now with shape, what we mean by shape, okay, what we're asking about with shape is we're asking about how it looks. So when we look at a dot plot, there's going to be certain things that we look at, how it looks. And so we're going to ask you about that. Like, are all the dots on the left? Are all the dots on the right? Are they kind of all in the middle? And we have some words that we're going to use to describe that. And the way we describe shape of dot plots, and when we get to box plots here in the future, we use the word skewness. And skewness is going to mean that we're going to be all on one side. So skewness means that how the dots are shifted. So again, we're going to be not talking about so much what the shape looks like. We're going to use the word skew. So are they shifted left? Are they shifted right? Where are the dots? So that's where they shifted. Okay. So there's 3 types of shape in dot plots. Okay. And what you guys have discovered yesterday is that we have something we call skew right. Well, the opposite of skew right would be skewed left. And then the last of them was, what if we don't really have them? What if they're not all the way on the right or not all the way on the left? What if they're nice and easy and even and form like a dome shape? And we called that symmetrical. So those are the 3 types we're going to look at today. So again, just review. Skewness is how we define shape of a dot plot and box plot. And we can have either a shape of skewed left, a shape of skewed right, or the dots on the box plot can be what we call symmetrical. The symmetrical being that it's evenly distributed on both sides. All right, so let's take a look at this graph. Now this is a dot plot, and we can kind of notice that there's kind of a slope to it. And you can see this guy here is a skier. Now, the reason why I have him here is because when I think of skewness, skew kind of sounds like the word ski. So I want you guys to think of these dot plots kind of like mountain slopes. So we're going to draw a line that covers the whole top of all the dots from left to right. So I'm going to start right here in the middle, or the highest point, the mode really is 10. You should know that from last time. And I'm going to draw a line that goes over the top and kind of traces the way that these dots go. And if I go to the left, well, it goes straight down. Okay. So what I want to know is, which way do you think it would be safer for the skier to travel? Let's say this is Coach Novosad right here. This guy right here is Coach Novosad. And I want to know, which way should Coach Novosad go? Should he go to the right in a nice smooth slope? Let me move him up. So if he goes to the right, we know he's going to go down this nice, smooth, not very steep slope. Or he could go to his left and go down a very steep slope and probably perish to his death. So for those of you that have Coach Novosad and like him, I'm assuming that most of you guys want him to go to the right. Hopefully nobody wants Coach Novosad to go to the left. Now we call this actually skewed right. So this is an example of what we would call a skewed right dot plot. Because now this can be confusing, because you're like, well, all the dots are over here on the left side. They're higher on the left, and you're right in that. So when we look for skewness, what we're looking for is, which direction does this tail off to? Which direction is a smoother ski slope? Okay, because I want to ski to the right, so we call this skewed right. So again, just to review, skewed right, we see a higher number of data points on the left-hand side of the graph, the plot, less on the right. So we want to travel to the right on the ski slope, so we call this skewed right. So let's take a look at another one. So again, we got Coach Novosad here on the bottom, and he wants to ski. Okay? So what do we notice when we draw our ski slope, starting from the mode of 60, because that's the highest point, I notice that it's a nice smooth slope to the left and a steep plunge to his death on the right. So when I move Coach Novosad up, which direction do you think Coach Novosad should ski? Should he ski to the right and plummet to his death? Some of you may think that's true. I hope not, but it could happen. Or do we want to flip him around and ski to the left? Well, personally, since it's about me, I want to ski to the left. So we call this type of graph skewed left. Because I know I want to travel this direction because I'll be safe versus this way, and I plunge to my death. Okay, so let's talk about the shape of the graph. Now, we know which way he wants to ski, but why do we call this skewed left? Just like skewed right, it's kind of opposite, right? We see most of the dots, most of the data points are on the right-hand side versus very few are on the left. So when we look at that, when we see a lot of the data points on the right, few on the left, we know we want to travel to the left. We're looking for the tail of this line, or where the slope is more gentle or more friendly for a skier. We call this skewed left. So again, review. If data points are high if I want to ski to the right, it's skewed right. If we want to ski to the left, it's skewed left. Let's look at one. Now, you can see on the bottom here, this is symmetric. And the reason why we call this a symmetric, or symmetrical, spelled that wrong, is because no matter where I put Coach Novosad, right, either way is pretty safe to travel down. Now, another way we can notice that this is symmetrical is because when we look at our line and we look at the data, okay, the highest point or the mode is right in the middle. Right? In our skewed left and our skewed right, so like a skewed right, our mode, this is my line, skewed right, the mode is over here on the left, right? We have a lot of dots and they get smaller and smaller. Skewed left, I have the mode over here on the right, and then it gets smaller and smaller. So there and there. With symmetrical, this is right, this is left. With symmetrical, it's pretty even. The highest point or the mode or the highest tower is in the middle, and then it's pretty even on either side. Now this is a great example of a perfectly symmetrical. There's no guarantee that you will see that, and more than likely in real life it's hard to get that, but it doesn't mean it doesn't happen. So this is what we call symmetrical, because no matter which way Coach Novosad skis, to the right, or we can flip him around to the left, it doesn't matter which way he goes, he'll be safe. So we call that symmetrical. So let's review. So we're going back and looking at your statement, your I can statement, your learning target. So what you need to get out of this video is being able to identify. So you should be able to tell me now the shape of a dot plot and using these three vocabulary words: skewed right, skewed left, or symmetrical. And you can justify why something is skewed right or skewed left or symmetrical of a dot plot. So let's talk about symmetrical, because symmetrical, we can say it's even on both sides, right, of the mode. Okay, so where the mode's at, I can go down on the right, down on the left, and the shape is pretty even. The lines look even. Now, when we go look at skewed right, we have to think opposite. So skewed right means that a lot of the data, the majority of the data, is left but the tail or the ski slope goes to the right. Okay, remember, where does Coach Novosad want to ski? To be safe. Okay, so skewed left, we're going to say, well, all the data is on the right, but our tail, okay, it's going to go this direction. So Coach Novosad wants to ski. So skewed right, remember, it's going to look something like this. Skewed left, it's going to look something like this. Symmetrical, we call it the bell curve, right? Nice and smooth and even distributed on both sides. All right, so at this point, what you're going to do is you're going to click on the next slide. Now remember, this assignment is for a grade, so when you log in, you need to do these notes that follow, or this assignment. You have some fill in the blanks. You're going to get pictures of some dot plots. And what we want you guys to do is tell us, is it skewed right, is it skewed left, or is it symmetrical, and be able to justify why that is true. So give reasoning for your answer. Don't just put right and move on. Tell me why it's right. You know, tell Miss Elisa, Miss Lee why it's right. Okay, so be able to justify. Because remember, we're not just asking you, can you identify? We also want you to justify, which means tell me why it is your answer is what it is. So I hope you guys are doing great. If you need any help, please contact your teacher, and we'll talk to you guys soon.